we're about to derive equation 5 here. It turns out the key to deriving equation 5 is looking at equation 2. We know that VF is equal to VI plus AT. And from here, what I can do is I can rearrange this equation to solve for VI. In order to do that, I know I can just bring AT over to the other side of the equation by subtracting it. Okay, so I'm left with VF minus AT. Okay, and this is just a rearranged form of the second equation that we've derived so far. Now, the key to deriving equation 5 is I'm going to take this rearranged equation 2 and substitute it into equation 3. Okay, now here's what that's going to look like. Here I have equation 3. Okay, this is equation 3. I'm going to take VI from above, and I'm going to sub it in for VI in my equation 3. So when I make that substitution, I no longer have VI. In its place, I have VF minus AT times T plus 1/2 AT squared. Okay, so at this point, what I want to do is sort of clean this up. I'm going to expand this T into the brackets, okay, just using a simple distributive property. Okay, when I do that, I have a T multiplied by the VF. I'm subtracting A times T squared. Okay, and I'm still left with this 1/2 AT squared. What I have here is two terms that we could consider like terms. Okay, so at this point what I'm going to do is collect my like terms. Okay, so I have a negative AT squared. I'm adding 1/2 AT squared. So if I take 1/2 and I add it to -1, I'm left with negative 1/2 AT squared. Okay, this is what they call equation 5. Just a little tip here, like, well, why did you pick 2 and then sub it into 3? Just a little tip I'm going to give you. Keep in mind we're trying to derive equation 5. Equation 2, if we rearrange that and sub it into equation 3, we get equation 5. And a nice little memory aid for that is 5 is equal to 2 plus 3. Okay, so if you're having a hard time remembering which equations to select, remember this little tip.